In this video we will learn about the Cobb-Douglas elasticity of substitution. We have the understanding of what elasticity of substitution is, and we have developed its three formulas before, out of which the first one is this one, and then the second one, the third one. The first one was with the slope of isoquant in the denominator. Other one was with the slope of or the proportionate change in the ratio of the prices, that is the slope of the budget line, and this one was by using the partial derivatives. So we are going to use this one. It is suitable because we have the Cobb-Douglas production function in its standard form, and it is easy to calculate its derivative with respect to the first factor of production and then the second one, and then differentiating this marginal product with the second factor of production, and the production function itself can be written here, and this ratio can be easily solved. So let us start with the solution for f1, which is the derivative of the production function with respect to the first input, that is v1. So this is the production function. We differentiated it with respect to the first input, and we are going to solve this. We have extracted those terms that didn't have v1 in it, and now we have the term with v1 in it. For this derivative we apply the power rule, and it is easy to apply, whereas this term remains as a coefficient. Now we can write it like this, in which the coefficients are appearing first, then v1, and then finally v2. So this is f1, and finally the other factor of production v2 at the end. So it is in a good sequence. Now we try to find out the other required derivative, that is f2. For f2 we have to differentiate the production function with respect to v2, the other factor of production, and this is the derivative, this is the production function, and now the power rule is applied after we extract these two variable and coefficient from the given production function. Now the power rule is going to help us here. We have applied the power rule. Beta was the power, and it changed here in two ways, that is as a coefficient as well as 1 was deducted from its power. Now this is the form after we bring beta at the end of this, and we can write it like this. This is a more consolidated form because the two coefficients, they are coming first, and then there is v1, and then there is v2. So we have developed f2 as well. Now we need f1 too, and for that we just need to differentiate f1 with respect to v2, because this is the second order cross partial derivative. f1 is already found. We found it here in a few steps, and now we are going to take its derivative with respect to delta with respect to v2. So delta over delta v2 will appear, and this is f1. It is again easy to calculate simply by using the power rule. This is the result of the derivative, and this is the term that we have for as a coefficient. Now f12 is found, and it looks like this. Recalling the formula, because now we are in a position to put all these values and find out the sigma value, f1, f2, f12, q. Now the substitution is easy. This is f1 as I have highlighted here. The value of f2 is here, and the value of f12, it is here. The value of q, the production function itself, is here. We can cancel out the terms that can be cancelled, and you can see that all of the terms are cancelled out. Therefore the answer is 1. It shows that in Cobb-Douglas production function, the elasticity of substitution, sigma, between v1 and v2, the two factors of production, is unitary in terms of value. So the Cobb-Douglas production function is actually unitary elastic production function. So we can say in as interpretation of this result that 1% change in the ratio of the factor prices will lead to 1% change in the ratio of factor proportions in the opposite direction. Now this interpretation is in lines with this formula, that is 1% proportionate change in the factor proportions is caused by 1% proportionate change in the ratio of the prices of the two factors. So this is that definition that is used here for the interpretation. And this opposite direction is also mentioned here. It is natural because when one factor of production gets expensive as compared to the other factor of production, its demand will decrease. So it means that there is a negative relationship here. Therefore, a 10% increase in P1 relative to P2 will lead to 10% reduction in V1 relative to V2. So this thing must be remembered, that this is not the direct relationship in the sense that one variable is getting affected due to the other variable. We have a relative sense of effect because the change in P1 is relative to P2 and the effect on V1 is relative to V2, because we have to make a choice between V1 and V2, that how we increase or decrease one of them. So this is how the elasticity of substitution can be calculated, by using the formula with the partial derivatives out of the three formulas that we learnt, and the value of the Cobb-Douglas elasticity of substitution is equal to 1, making it a unitary elastic production function. Thank you.